we're going to look at assignment 33, problem 82. So when you look at the picture of this, there's a lot going on. Again, these are just not simple conservation of momentum. What's going to happen is you have a bunch of different things going on. So when you look at the picture, you have a bullet that's moving along and it becomes embedded into a block. But then what's going to happen is it's going to go on this track. So it says a bullet of mass m collides perfectly inelastically. So that means they go together and they're a combined mass. So they move off with one velocity with a block of mass 4m that is initially at rest. Determine the minimum speed the bullet must have to complete the loop and answer in terms of m, r, and known constants. So that would be little g. So in the first part, when I think about conservation of momentum, the total momentum before is going to be the total momentum here. So what I'm going to say is mv naught plus 4m, and then that would be v naught. This would be the bullet. This would be the block, is equal to m plus 4m times v naught. So that's going to be to the point here where now the bullet is in the block. So I'm using conservation of momentum from here to here. Well, this is at rest, so that goes to 0. So I have mv naught, this is the velocity of the bullet, is equal to 5m times v prime. The problem here is this is unknown and this is unknown. So I'm going to have to do something else to find some of these variables. Well, when it says what is the minimum speed, now I'm looking at a circular motion problem. Now, I don't memorize stuff, so when we did circular motion, we said the centripetal force is equal to the gravitational force. So mv squared over r is equal to mg, and my m's cancel, and if I rearrange this, I get v is equal to the square root of rg. Some people just like memorize that, but again, you can write this out, and on an FRQ, they're probably going to ask to see these intermediate steps and not have you write that. But that's the speed at the top. We still don't know what v prime is, which is right here. So this v is the v up here. We still don't know the v at the bottom. So to find the v at the bottom, now what we're going to do is we're going to use conservation of energy. So conservation of energy is we're going to say that total energy here is equal to the total energy here. So we're going to say UG naught plus K naught is equal to UGF plus KF. And this is going to be the bottom, and then this is going to be the top. Well, at the bottom, remember, this is going to be our frame of reference, our base level. So at the bottom, this is going to go to 0. But at the top, we're going to have both gravitational potential energy and kinetic energy. So now I have 1/2 at the bottom, 5m v prime squared is equal to 5mgh plus 1/2 5m v squared. So the first thing I'll do is I'll cancel all the 5m's. So now I have 1/2 v prime squared is equal to gh plus 1/2, and because I have this v, which I found here, I'm going to substitute that in, the square root of rg squared. Now this problem, it all has to be in terms of m and r. So I have to now look and say, okay, what is this height here from the bottom to the top? Well, if I know the radius of the circle, the height is going to be 2r. So I have 1/2 v prime squared is equal to g times 2r plus, when I square all that, I'll get 1/2 of rg. So now it's all in terms of my variables. I want to get rid of that half, so I'll multiply everything by 2. So v prime squared is equal to 4gr plus rg. So v prime is equal to v prime squared is equal to 5gr. So v prime is equal to the square root of 5gr. So that gave me now v prime. That gave me v prime, which is the velocity of the combined mass at the bottom. Okay? But remember, I want to find the initial velocity of the bullet. So now I'm going to go back, and I'm going to use my conservation of momentum here. And now I'm going to say v naught is equal to 5m times v prime over m. So the m's cancel. So it's 5v prime, and then I'm going to substitute in v prime, so it's 5 times radical 5gr. And that's equal to v naught, the initial velocity of the bullet before it became embedded in the block. And that's all in terms of the variables that they asked for. So again, when you do a problem like this, don't just say, oh, what equation am I plugging in? That's not how you do physics. You're saying from here to here, I'm doing conservation of momentum. From here to here, I'm doing conservation of energy. Because they asked for the minimum speed, oh, I have to go back and think about, when I talked about circular motion, as far as what's the minimum speed, for it to do that. So this is really a 3-part problem. And that's the way you solve problems in physics. You're not just plugging numbers in an equation.